Hello, everybody. I'm Tiran Sunny. Uh, I've chosen a research topic based on machine learning and deep learning for class IT 282, Advanced Communications Concepts and Visual Presentation. Let's see what machine learning is. Machine learning can be defined as a branch of artificial intelligence which uses a computer to generate rules based on raw data that has been fed into it. Machine learning is also a scientific discipline considered with the design and improvement of algorithms that allows computers to evolve behaviors based on empirical data from sensors or databases. Beyond these definitions, machine learning is the key to facilitating the description of a problem solving platform. It is a mechanism for a pattern search and building intelligence into a machine to learn and imply it so that it is able to do better in future from its own experience. In basic words, it's all about knowing and using data appropriately, which includes collection of the right data, learning, modeling, and algorithms. Role of machine learning. The main role of machine learning takes place when they improve performance or take accurate predictions using computational methods implying experience. Experience here refers to the information available to the learner in the form of electronic data which are used for analysis. The data might be in the form of digitalized, human labeled training sets or other types of information available from the interactions with the environment. In machine learning, we will additionally need a notion of sample complexity to evaluate sample size required for the algorithm to learn a family of concepts. More generally, theoretical learning guarantees for an algorithm may depend on the complexity of the concept classes considered and the size of the training sample. The success of the learning algorithm depend on the data analysis and statistical data used in machine learning. Learning techniques are data-driven methods combining fundamental concepts in computer science with ideas from probability, statistics, and optimization. Now let's talk about the working of machine learning. Data forms are the main source of working in machine learning. The working of machine learning depends mainly on two types of data sets. The first data set is manually prepared, consisting of input and output data which are available. The second data set is one in which we have input the data and it predicts the expected output. Basically, there are three phases of performing machine learning. The training phase. This is the phase in which the data is used to train the data by preparing the given output and with the expected output. Validation phase. This phase is used to measure how good the trained learning model is and to estimate the model properties such as error measurement, recall, precision, and others. This phase uses a validation datasets and the outputs is a sophisticated learning model. The third phase is the application phase. In this phase, the model is subject to real world data for which the results need to be derived. Let's come to the most important concept of machine learning. Yes, the applications of machine learning. First and foremost, software. The machine learning is widely used in software to enable an improved experience with the user. With some packages, the software is learning about the user's behavior. After the software has been in use for a period of time, it begins to predict what the user wants to do. Spam detection. Spam detection is one of the classic examples of machine learning, and over the time, algorithms have got better and better. Voice recognition. Over the years, the voice recognition has been improving. Apple's Siri, which is present on the iOS platform, and Microsoft Cortana, present on the Windows platform, are examples of voice recognition tools which uses machine learning. Stock trading. There are a lot of platforms that helps users to make a better stock trades. These platforms have to do large amount of analysis and computation to make their recommendations. From a machine learning perspective, decisions are being made for you on whether to buy or sell a stock at the current price. It also takes into account the historical opening and closing prices and volumes of stock trades. Furthermore, there are applications in marketing, automating control of employees, animal protection, healthcare, robotics, and etc. Deep learning. Deep learning is a branch of machine learning that deals with the linear and non-linear transformation, which is based on a set of algorithms to the high level abstractions with multiple processing layers. Deep learning is also a division of machine learning based on learning representation of data. It is mainly based on iterative algorithms, nonlinear transforms, and learning at multi levels of abstraction. Deep learning is also characterized based on algorithms that use a cascade of many layers of nonlinear processing units for future extraction and transformation. Each successive layer uses output from preceding layers as input. Deep learning also helps to make it possible to make machine learning closer to the artificial intelligence. Role of deep learning. Deep learning is a class of machine learning that involves successive layers of learning that correspond to the different levels of abstraction. The composition of layer depends on the problems to be solved. Layers used in deep learning include hidden layers of an artificial neural and set of complicated formulas. It allows computational models that composed of multi-processing layers to learn representations of the multi-level data abstraction. These methods are particularly used in visual object detection, object recognition, and many other fields. Deep learning is making advances in solving problems that have resisted the best attempts of artificial intelligence community. It is very good at discovering intricate structures in high-dimensional data, and therefore it is applicable to many domains of science, business, and government. Deep learning has produced promising results for various tasks in natural language understanding. Various new algorithms and architecture are currently being developed for deep neural networks, which will only accelerate this progress in deep learning. There are many benefits of deep learning: reduction of workload, multiple domain solutions, it's easier to work on multi layer processing, it is made of connection of machine learning and artificial intelligence easier. This figure shows how deep learning can be applied in science and engineering. Applications of deep learning. Deep learning has been achieving a great result across a wide range of domains. There is a lot of research going on in artificial intelligence, machine learning, and deep learning. There are various applications of deep learning. Image caption generation. Automatic image caption generation is a task in which a given image to the system generates the contents of the image. The system uses a large convolutional neural network for image detection and then a recurrent network for turning the labels into a sentence. Automatic image machine translation. This is a task in which a word, sentence, or a phrase is translated into another language. Deep learning has been involved in two specific tasks of translating the text and image without pre-processing so that the algorithm could learn the dependencies between the words and the mapping into a new language. Weather forecasting and event detection. This was traditionally done using supercomputers, but with deep learning growing, it's been using neural networks to detect the pattern. Automatic speech recognition. Speech recognition, which revolutionized with deep learning using long short term memory, otherwise known as LSTM, which is a recurrent neural networks. Furthermore, there are applications in management of customer relations, discovery of drugs, language processing, etc.